I'm going to show you guys how to do the bridge in SolidWorks. Now, chances are you're going to have some sort of folding thing happening with your bridge. And I know Mr. Pratt has shown you how to do some extrusion and stuff like that, but you guys haven't done any of the sheet metal stuff as far as I am aware of, okay? So I'll show you how to do that, and then I'll show you how to unfold it. And the reason we need to unfold your bridge or your design is what we're going to do then is we're going to import it into a engineering drawing or a two-dimensional drawing, and then we'll export that to Illustrator, and then we can actually laser cut your design and your template, and then you just fold it the way you want it to fold it, and there's your bridge, okay? All right, so I'm just going to show you like a really basic truss bridge, but your designs can be completely different. You can use the same principles as I'm using here that you will use with your design, okay? So if you want, you can after I've finished, you can follow along and try to do this truss bridge, or if you like, if you feel like you've got your own design happening, you can do that, okay? All right, so here we go, guys. So what I'm gonna do first is I'm gonna start off just by creating my bridge. So I'm just gonna use some simple extrusions. So I'll just work on my front plane normal 2. Okay, just gonna zoom in, and what I need to do here is just I'm gonna sketch a bit of a triangle here. Okay. Using these guides. Okay, and then I'll make sure this goes down here. Now I don't want a closed triangle, and the reason is because if it's a closed triangle, then I can't unfold it. Okay, so if you imagine that this is your piece of cardboard, and then you folded it into your triangle, you're always going to have an opening. Okay, you're always going to have an opening. Now, what I would suggest is that you have a flap or another side that will actually attach to that. Okay, so questions at the end. So you'll always have it open. So you really need to make sure that you've got an opening, because we won't be able to do the sheet metal stuff otherwise. Okay, so keep that in mind. All right, so here we go, guys. I'm going to dimension my my triangle. Okay, use a smart dimension tool. Okay, I'll dimension this. Okay, 62 millimeters. That's about 6 centimeters across. That's not too bad. I'll probably want it a little bit bigger, so I might make that 100. Okay, 100, which is about 10 centimeters, which is 10 centimeters. Okay, and that's not too bad. Okay, I might leave that. I'm happy with that. Okay. All right. So what I'm going to do now is I'm going to extrude using a thing called the thin feature. Okay. So I don't actually need to sketch another line all the way around and then join it. Okay. I can just extrude this line and just tell SolidWorks that the thickness of that extrusion is 5 mils, which is the thickness of your cardboard, okay, which is the corrugated cardboard that you're going to use, which we've ordered. I don't know if you guys have seen it already, but we've got it in the loading dock. So here we go, guys. So feature, extrude. It'll probably go to the thin feature straight away, okay, and the thickness of that will make 5 millimeters. Okay, so defaults to 10, and I want to extrude. Now, the size of your bridge needs to span 600 millimeters, okay? Which means your bridge needs to be bigger than 600 millimeters, otherwise it'll just fall through the gap. You need some bits on the edge, so it's actually sitting on the bench. Okay, so this extrusion needs to be bigger than 600 millimeters. Okay, so here we go. So I might make it 750. Okay, 750. Okay.
Oh my.
Click OK. All right, I'm happy with that. Beautiful. All right. So now I might think, well, hang on. Okay, so I've got this sort of triangular bridge type shape, but you guys are being marked on the efficiency of your structure, right? Because this is engineering studies, right? So you might think, well, hang on, how am I going to make my bridge more efficient? Okay, an efficient bridge is one that weighs as little as possible and holds as much as possible. Okay, so we're actually going to divide how much your bridge weighs versus how much you can hold, and you guys aren't to use glue as well. I don't know if that's going to explain to you. Okay, so no glue. Questions at the end. What you need to do is think about, all right, well, actually, I'm using quite a lot of cardboard here, and it's going to be quite heavy. So what I might need to do is reduce the weight without reducing the structural integrity too much. Okay. So what I'm going to do is I'm going to cut some triangles, and then what's left over will be my support beams. Okay. So I'll show you how to do that now. And I'm only going to do one. I'll see how we go. I might array the rest later. Okay, so here we go. So what I'm going to do is on my right plane here. Okay, on my right plane, just here. What I'm going to do is I'm going to go normal to just like that. Right. I'll make that bigger so you can see it. And so you can see that right plane is in the middle, and it's cutting through this sort of triangular prism shape. Okay, so what I'm going to do, I'll go normal to again, which is just up here. What I'm going to do is I'm going to start to draw my triangular shape. Okay, I'm just going to do one. Okay, actually I might do two because then I might be able to array the rest of them. So
how do you cancel? So what you just
escape. Press escape.
Okay.
If you don't quite meet the end point of your lines, you're not going to be able to extrude because you won't have a valid profile. So what I've done here is not really good, right? I haven't been very careful in terms of joining those dots. Okay, so I might actually drag that, or you can redraw it if you want. I might actually click and drag that over, and now I can see that it's actually the two are actually touching. If you want to make yours an equilateral triangle, then you can actually dimension your angles as well. Okay, just by clicking on those two lines. What should that degree be? Who can tell me?
60.
No. We'll do 60. And then this one. What's an equilateral triangle, guys?
60, 64.
Okay.
Everything is equal.
There you go. So all your angles are equal, and all of your sides are equal. Okay, that's an equilateral triangle. Okay. So what I might do is I might do another equilateral triangle, but upside down here. So I get a nice beam going across here when I cut that through. Okay. So I'm going to do another equilateral triangle just on the other side. So again, I'm going to get my straight line tool, and this time I'm going to just sketch like this, line it up. Okay. And again, I'm going to get my smart dimension tool, and I will make sure that it's 60, 60, 60. If you dimension two sides to 60, the third one will be 60 automatically. 60.
So you didn't click the right.
Okay. No, that's right.
No.
Is that right or not?
No, you didn't click the other.
Okay. From here to here. Okay, yeah, you're right. Thank you, Adam. Okay, there's my equilateral triangle. Wonderful. And what I want to do also, these are already lined up because when I drew it, I made sure that they're lined up. Okay, so I'm happy with that. So what I'm going to do now what I'm going to do now is I'm going to extrude cut, just like that, and because my plane is in the middle, I need to extrude cut from both sides of the plane. Okay. If my plane was here somewhere, then I could just extrude cut one way. But because my plane's running in the middle, okay, I need to go from both sides. Okay. So instead of clicking blind, or instead of leaving it on blinds, you'll actually go to mid plane. Okay, and I'll just increase that to whatever it needs